All right, here we go. 2010, number one. You get graphing calculator on the first three on this test. It does change to two, I believe, in 2012 when you get two with a calculator and four without. But here we go. Basically, it starts to snow, and they give you an equation for the rate at which snow accumulates. And then Janet starts shoveling snow off of her driveway at 6. And here's the function that tells how fast she shovels snow off of her driveway. And then they ask you questions about how much snow is left on her driveway, and so forth. So um, let's see what we got with this. How many cubic feet of snow have accumulated on the driveway by 6 o'clock? So before she starts shoveling. Um, well, they give us a function in cubic feet per hour of how much snow um, is accumulating, and I want to know how much snow there is on the driveway. So remember, we talked about this, and this comes up a lot. This is the most common use of integrals, probably, when we have cubic feet per hour, and then this is hour. So whatever this might look like, the area under the curve is going to represent cubic feet per hour times hour. This is going to represent cubic feet. Okay, so you need to be thinking whenever you're given a rate function, the area under the curve is going to give you the amount that you accumulate when because when you multiply these two together, the hours will cancel out. Okay, so that's kind of how you're approaching this problem. So, starting fresh, we look at this. A, how much cubic feet of snow have accumulated on the driveway by 6? So the amount on the driveway, isn't that just going to be the integral from 0 to 6 of f of t dt? And since I have my calculator, it's going to be 0 to 6 of 7t e to the cosine of, if I can get this, cosine of t dt. And if you do that right in your calculator, you should get 142.275 cubic feet. Okay, so that's how much snow is accumulated by 6 o'clock. B. Find the rate of change of the volume of the snow on the driveway by 8 o'clock. So we want, rate of change of the volume of snow on the driveway by 8 o'clock. What does f of 8 represent? That represents the rate of change of the snowfall, how much snow is falling onto the driveway, and I subtract from it how much snow is being shoveled off of the driveway. So this is going to represent the rate of change of the volume of the snow on the driveway at 8 o'clock, right? This is how much is falling onto the driveway, and this is off the driveway, what she's shoveling off. So this is going to be the net rate of change of what's on the driveway. And so if I simply calculate that, f of 8 minus g of 8, that's going to be 7 times 8 e to the cosine of 8. Make sure your calculators are in radian mode. Minus g of 8. G of 8 is 108. And if you do that, you get negative 59.583 cubic feet per hour. So at 8 a.m., it is, what's happening? Or is it increasing or decreasing cubic feet per, how much snow is, what's the rate of change of the snow? It's decreasing by 59.583 cubic feet per hour. C. Let h of t, now this one you have to really kind of think about a little bit. And once you recognize what it's asking, then it's not such a big deal. But initially it can be kind of confusing. So h of t is the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. Express h as a piecewise defined function with domain t is 0 to 9. So this is the total amount of snow that she's removed. This right here is the rate of change, or the rate at which she removes the snow, right? the rate she removes the snow. We want the total amount of snow. So h of t equals the total amount of snow removed. Okay? And we want it from 0 to 9. Well, from 0 to 6, how much has she removed? Good, none. So we'll say, do it like this. From 0 less than or equal to t less than or equal to 6, well, I guess we'll say less than 6, h of t equals 0. Okay? Then we want to say, okay, from 6 to 7, how much has she removed? So from 6 up to 7, how much has she removed? Well, how do you figure out how much she's removed? Well, isn't that the integral from 6 up to t? If I wanted the total amount from 6 to 7, it'd be the integral from 6 to 7. But since t is any value between 6 and 7, then that would be the amount she removes is the integral from 6 to t of g of t dt, which in this case, since it's between 6 and 7, that's 125, right? And so if I go ahead and do that integral, that's going to be 125 t. Now this is a little bit maybe bad notation, but we're going to go ahead and go with it because I use have a t here and a t here. I probably should use a different variable like x from 6 to t. So it's going to be 125 t minus 125 6 times 6. Okay, so this would be my expression for how much snow she's removed at any time t between 6 and 7. Okay, now we take a look at from 7 to 9. And we can go right up to 9 o'clock. H of t, same reasoning. Now once you understand that, then it goes fast. G of t, again, this is going to be 108. So she slows down a little bit, getting a little tired. dt is going to be the 108 t from 7 to t, which is 108 t minus 7. Now, I didn't include one thing here, though. This is the total amount of snow she removed. This expression right here simply represents how much she's removed from 7 to t, from 7 hours up to t. She's already removed the snow from 0 up to 6. And how much has she, or up to 7, I mean. How much snow has she removed up to 7? Well, if t is 7, this is up here, it's 7 minus 6 is 1, so 125 cubic feet. So I'd better add 125 on the front here, on the front side of here. It really is 125 plus 7 to t, 108 dt. Does that make sense? So really, I'm going to do that, which is 125 plus 108 times t minus 7. That's my formula for 7 to 9. Okay, does that make sense? So again, just to recap this part of the problem, it's the total amount of snow removed, which is the integral of the rate of change of snow, because g is the rate. And so from 0 to 6, she's got removed 0. From 6 to 7, it's the integral from 6 to t for any time t in that range. And so I take the integral of that. And from 7 to 9, she already removed 125 cubic feet, right? Because when t is 7, that's 7 minus 6 is 1 times 125 plus 7 to t, and you get that expression. Okay, so then D, how many cubic feet of snow are on the driveway at 9 a.m.? At 9 a.m. Well, we need to know how much has fallen on the driveway. 0 to 9. That's how much is on the driveway. And then I have to take off how much snow has she removed. That's H of 9. So I'm using what I learned in part C. So this is the amount. Let me scoot up here. This is how much amount on the driveway, or I should say this, how much amount fallen, and this is the amount removed. Okay, and so again, the first part is done on your calculator, and H of 9, I'm going to plug it into here, and if you do both of those on your calculator, you should get 26.335 cubic feet. Okay, and you know what? You probably ought to add up here cubic feet. There's no mention on the rubric when it gives you points for answers to add units. It just says answer. But since this is a problem that has context in it, I would absolutely add the units in there on here. Okay, there you go.